you read that in your own time, and then we'll be thinking about that sort of thing in a minute. Right. So you've all considered the problem that's on the board then, and most of you have decided that Janet is not creative. The thinking that is behind that underpins everything that I'm going to be talking about tonight, really. But for the moment, I'm not going to give you a definitive answer, because we're going to be talking about that throughout the talk. Okay, today I'm going to be talking to you about artificial creativity. This is a branch of artificial intelligence that I'm particularly interested in, and hopefully by the end of the talk you may see why. Artificial intelligence is a weird area of science for a few reasons. For a start, the research outdates the invention of what you and I would call the computer. Also, it includes a huge range of disciplines, for example psychology, for reasons such as we've just discussed, for saying what is and what isn't creative, physics for building things such as quantum computers, biology for building things such as neuron nets, computing for obvious reasons, and etc., many more. For me, this makes it even more interesting. Artificial creativity has been a dream for computer scientists for a long time. On the board you can see a quote from Alan Turing, who many consider to be the father of computer science. In 30 years it will be as easy to ask a computer a question as it will be to ask a person. This still isn't true, but hopefully I can show you why. To understand artificial creativity, or even to have a hope of building an artificially creative agent, you must first understand what creativity is in humans. This is how dictionary.com define creativity: the ability to transcend traditional ideas, rules, patterns, relationships, or the like, to create meaningful new ideas, forms, methods, interpretations, etc. This definition is okay, but it really doesn't explain what the difference is between things that are creative and things that aren't. Let's think of an example. A robin creating a nest is creating a new product. The product serves the purpose that it was created for. Therefore, it's a meaningful new idea, such as the definition. But is the robin just following its instinct, or is it being truly creative? Here is a better definition from a man called David Cope. He has years of experience in computer-generated music that I'll come on to later. The initialization of connections between two or more multifaceted things, ideas, or phenomena, hitherto otherwise not considered actively connected. This definition is a lot better. It seems to describe a second level of creativity, one in which things have to be revolutionary. For example, I'm generating a new sentence right now with relative ease, but is this truly creative? This is the difference between things that are creative and things that are truly creative. This is referred to as deep creativity. Deep creativity, defined by David Cope, is something such as Schoenberg dropping musical keys to create atonal music. Before he did it, it was thought to be impossible, or at the very least, not worth trying. He created a whole new style of music, and I'm sure you can see the difference between this, or my sentences, or the robin. So, that is what creativity is. What makes up creativity? Well, there are two main components: unpredictability and conceptual spaces. The unpredictability part is quite easy to understand. It's just randomly generated ideas used by us to start on the creative journey. For example, in people, you have the case of a jazz drummer who suffers of Tourette's syndrome. As a result, his drumsticks sometimes make unexpected sounds, but the man's musical skill is great enough that he can work these into the music as he goes along. At worst, he covers them up, but at best, he used them as the seeds for improvisations he couldn't have thought of without them. The conceptual space part is harder to understand, and even seems paradoxical. This is the set of rules that are used by us to create a meaningful thing. For example, sonata form in music, or the idea of painting a portrait in art. What makes people such as Mozart so much better at creating things than the rest of us is that his brain can navigate his cognitive maps much more easily. He knows the conceptual space of music inside out. Studies in children have shown that they have unconscious ideas about what can and can't exist. For example, it's very difficult for a young child to draw a picture of a one-armed man or a seven-legged dog before developing such skill maps. They can create simple things, but they aren't deeply creative because of their lack of understanding of the conceptual space. Therefore, the things they're creating aren't revolutionary, and they aren't deeply creative. How then do we apply all this to computers? In theory, computers should be really quite creative. They're good at recognizing patterns, and they aren't constrained by social norms. Plus, they're quite cheap to run compared to humans, so you could be able to generate a piece of art just as good as a human, but for like a fraction of the price, just the energy bill. To get a computer to be creative, you first need to program it with the conceptual knowledge that we've just explained. Then, the computer needs to be programmed to explore this in a random way. And that's it, right? Well, it turns out that it isn't that simple. To start off with, random numbers are actually quite difficult to generate. A random number is something that's both unpredictable and has no pattern. Computers are a list of instructions, and therefore they're inherently predictable. One way around this is to use something such as a truly random input, something such as the rate of radioactive decay, or sampling noise on a radio signal. The second option is to settle for something called a pseudo-random number. This is something that's very difficult to predict, but it isn't truly random. You can use things such as sampling the keyboard rate of someone typing, and then use the least significant number as a random variable. You can also use maths to generate pseudo-random numbers, but you have to be careful because they're not completely random. John von Neumann joked, "Anyone who considers arithmetical methods for producing random digits is, of course, in a state of sin." The second problem is that the output of creativity is usually measured in something such as interestingness. It's very difficult to mathematically define interestingness, as I'm sure you can imagine. Therefore, the computer has no idea of how good the results it's creating are. Therefore, it can't have hunches, and the computer wastes a lot of time on dead ends. One key aspect of creativity is evaluation as you go along. Computers find it very difficult to criticize their own work for the same reasons. Even if all this was sorted out, then computers still wouldn't be creating anything new. They'd still just be regurgitating old ideas, and therefore this isn't deep creativity. My final question before I move on to some examples is whether we really want a computer generating content purely for our pleasure. Imagine a hypothetical storytelling machine. For the time being, we'll call it ShakespeareBot. ShakespeareBot will scan your mood as it goes along, will then correct the course of the story, and if your attention falls during like the descriptive passages, it'll skip over those straight to an action part. Promptly learn it won't make the same mistake happen again. Not to mention, every time you want a happy ending, you'll get it. This then, isn't it a sort of simple mental masturbation? Computers generating content purely for our pleasure, not stuff that's new or interesting? This can't be a good thing to be building society on. I mentioned David Cope earlier. His work in computer-generated music has proved to be quite controversial. On paper, music should be one of the easiest art forms to generate with a computer because of its mathematical foundations. For example, there are 7 notes in an octave, and the way you combine these to create the music follows a few simple patterns that are very closely linked to maths, which, as everybody knows, is the language of computers. Linking these rules with a random element then creates the music. Famously, during the 18th century, Joseph Haydn and others created musical scores for a dice-throwing game in which players rolled dice to determine which of the 272 measures of music would be played in a certain order. David Cope called his creation Emmy, and which is a combination of the words experiments in musical intelligence. To begin with, Emmy created scores of music in the style of other composers, such as Mozart, that experts couldn't tell apart from the originals. However, he quickly moved on to creating his own music. Emmy has written 3 original opuses in varying length and style. I'm now going to play you a sample of Emmy's music. think that something such as this is creative? Anybody? Shout out. Don't all shout at once.
It was incredibly repetitive.
Does that stop it from being creative?
No.
Okay. Could you tell it apart from music that had been created by a person? Do you think it's as good as some person's music?
It could be better than a lot of people.
It's better than my music when I'm playing instruments.
So, therefore, if it's as good as a human, surely then it could be creative, if humans are creative.
I think so. I think it still sounds nice to the ear, which makes it creative.
Okay.
But surely if you leave computers to make music, don't you end up with dubstep?
Right. Cope's work became more controversial when he started making comments like, if a machine can compose it, then what is so special about Mozart? This led to people dubbing him the Tin Man from The Wizard of Oz, who has no heart. Douglas Hofstadter, who was a prize winner from Indonesia, said, music is the way for humans to express their emotional information. No machine, no matter how sophisticated, should possess that power. Cope thinks the old cliché of beauty in the eye of the beholder explains the situation well. The dots and lines on the paper are merely triggers that set things off in our mind, do all the wonderful things that give us excitement and love of the music, and we falsely believe that somewhere in the music is the thing we're feeling. He just thinks of her as a tool. Everything that Emmy created, she created because of the software that he devised. If Cope had infinite time, he could have written 5,000 Bach-style chronicles. The computer just did it much faster. Eventually, however, the beauty he received got to him. This led to him deleting most of Emmy's software. He left just enough to demonstrate it for academic purposes. There seems to be a common theme in artificial creativity, with people getting very angry that computers can be used to generate art. However, people are more than happy to go and see what I'm going to show you next perform. Although it's called Vocaloid, and although it isn't strictly creative, I think it demonstrates nicely how computer entertainment may have gone too far. Her performance, if you can call it that, is generated by linking pre-recorded samples of music together with a hologram. People are more than happy to go and see this perform. So why is David Cope's music so offensive? Because all the people in the audience, they're real. Of course, this is Japanese, because that's the sort of thing they're into. I think another interesting point is that there was a huge row a while ago about the Royal Philharmonic Orchestra putting software into their hall so that, like auto-tune, the music be corrected for where you sit in the room. People got really angry about this, but then they're more than happy to go and see something completely performed by a computer. I think the problem is people get confused by things that are entertainment and not reality. Okay, that's probably enough of that.
Can you argue that that's there just sheerly for novelty value, rather than anything other than musical talent?
You could, but then what's wrong with things that are composed by a computer? It's still the same thing. They're still both there for the novelty and the entertainment. So what's the difference between people being happy to go and see that and not happy to listen to something composed by a computer? Nobody's forcing you to listen to something composed by a computer. People just get angry because you can. Okay, here's another example. This is called Aaron, and rather than music, Aaron creates art in the traditional sense, paintings, although obviously they're not painted because they're done by a computer. Art in this sense is slightly more tricky because there aren't as many strict rules that relate to it. In the image, you can see Howard Cohen, the inventor. Cohen's initial question were, what are the minimum conditions under which a set of marks function as an image? This led to him writing Aaron in 1973. Unlike most of the programs here, the name is not an acronym, it's merely a name beginning with the letter A, so that successive programs could be called B, C, etc. Initial versions of Aaron created abstract drawings that grew more complex through the 1970s. More representational imagery was added in the 1980s, First rocks, then plants, then people. In the 1990s, representational figures set in interior scenes were added, along with colour. What stops Aaron from being deeply creative is that it doesn't learn new things. All the styles have to be added by Cohen. Also, similarly to young children, Aaron's imagination is limited. For example, he couldn't draw a picture of a one-armed man or a seven-legged dog. Similarly to Emmy, and in fact all the examples I'm going to be talking about tonight, Aaron is written in Lisp. Lisp is a programming language based heavily on lists. In fact, its name is a combination of the words list processing. It's the second oldest programming language in the world. It's only 2 years younger than Fortran, which is a combination of the words formula translation. As I'm sure you can glean from the name, Fortran is a very rigid and longhand language, whereas Lisp was created as a shorthand notation for mathematics. However, it was quickly adopted by artificial intelligence because of the ease you can process large amounts of data in, lists. My next example is a bit different, although it is also written in Lisp. This, in my opinion, is the closest we've got to building a truly creative agent. The automatic mathematician does not just do sums. Instead, it comes up and generates and explores mathematical ideas, coming up with new concepts and hypotheses to think about. The idea was that it would learn from discovery and by playing with things that it found interesting. This is very similar to humans having hunches. The computer will assign ideas with an importance value, and then it will work through them in that order. Again, like humans. The computer's also wrong about its hunches some of the time. This, again, might remind you of humans. It has 3 parts, 115 initial ideas, such as concepts and basic mathematical knowledge, 184 rules of maths, and a metric for ordering how interesting it found the ideas. It's come up with some powerful mathematical notations, including an entirely novel theorem concerning a class of numbers called maximally divisible numbers, which his programmer had never even heard of. Douglas Lennart, who invented this, claims that the system also rediscovered Goldbach's conjecture and the unique prime factorization theorem. In short, it appears to be creative. However, after 200 mathematical concepts, the program slowed down and then stopped discovering things altogether. This is probably due to the limit of its knowledge. It couldn't add on what it already discovered, and therefore it isn't deeply creative. Some of the most interesting theory comes from trying to build machines that write stories. This is because it is very difficult, because the rules can be broken in some circumstances, and this makes the literature more interesting. Can you read the story on the board quickly, and then we'll continue when you finish. Most writers use empathy when writing about certain characters. If computers can do this, then they have to be conscious. Consciousness is the experience of hearing, smelling, feeling pain, etc. And computers can't experience these things. They can sense them at a very simple level, but they can't have the deep experience level that humans have. Therefore, they can't empathize. You can give them all your data, but they can't deeply create the same literature in the same way as a human can. For the same reasons, the computer can't empathize with the reader, and so it doesn't really understand who or what it's creating the content for. The end result, as I said earlier, is measured in interestingness, which is a bit vague, and for a computer to understand this, it has to be quantified in maths. This is very difficult to do, if not impossible. Also, perfect things aren't necessarily interesting. You can get a computer to play a piece of music perfectly, but it will sound nasty and robotic. But a computer can't see why this isn't right. It's the same with the literature. Quantifying even seemingly simple things is very difficult. For example, on the board, the story you just read is all about betrayal, as I'm sure you worked out. But at first glance, there is betrayal. However, is there really? A computer has to have a huge understanding to get this, whereas you got it almost instantly, I'm sure. The story on the board, in fact, was written by a computer called Brutus, as an example of what I'm talking about. But Brutus isn't deeply creative either. because for the same reasons as the previous two, it doesn't evaluate. The programmer has to add all the different styles. For example, in this, he has to add what is betrayal and what isn't. Therefore, the computer isn't deeply creative. At this point, I'm going to draw your attention back to the first question. Can computers be creative? The problem is still how you define creativity. If you use the dictionary.com definition, measured on just output, then yes, computers probably are creative. However, if you use definitions such as Bowden and Cohen, then computers are nowhere near. And in fact, it looks like computers may never be creative, because the output isn't what defines the creativity. In fact, how the output is generated seems to be the key. I would say that computers at the moment aren't currently creative. However, I wouldn't go as far as to say that computers will never be creative. Because if you look at humans, then we have a huge amount of information that we store in our brains, which we randomly access to create things. Then surely we can replicate this. One key problem is that people don't like the idea of computational creativity. Also, who cares if computers aren't deeply creative? Because it's the output we're interested in, isn't it? That's the bit that's useful to us, so why does it matter if it isn't deep creativity? I'm now going to introduce you to 3 tests of creativity. This is far better than a definition, and is in fact the way we measure it in humans. So why shouldn't this be the same for machines? The Torrance test, in fact, is a way of measuring creativity in humans. You may have heard of the Turing test as a way of measuring machine intelligence, and the Lovelace test is a more accurate way of measuring machine creativity. The Torrance test is the main measure of creativity in humans. It requires you to perform simple tests such as the ink blot test. Does this mean that if a computer could pass this test, then it'd be creative? Well, it's actually physically impossible for a computer to pass this test because it requires too much world knowledge. Also, it requires consciousness, which, as I explained earlier, computers just can't have. It's a mathematical problem that you cannot give computers consciousness. Surely then, this means that computers aren't creative. This isn't really fair though, because this test is aimed at people, not computers. The Turing test relies on a very simple principle. Say you want to find out if an object is 1 metre long. To do this, you get an object that you know is a metre long, such as a ruler. You then compare the two objects, and if they match, then both objects can be assumed that they're 1 metre long. Then say you want to find out if an agent is intelligent. Why not compare it to an agent that you know is intelligent, for example, a human? The Turing test consists of a human's judge, whose job it is to tell if the thing communicating with him through text on a computer monitor is a human or a machine. If the computer can trick the judge into thinking that it is a human, then it has passed the test. The first problem is that the judge could just guess, and then it would get the answer right 50% of the time. Therefore, the test needs to be repeated to get any sort of meaningful value. Asking a question of the computer that requires a lot of contextual knowledge will usually unmask it. For example, what's your opinion on fashion this month? The second problem is that even though there has not yet been any real success, the test is still far too easy. It's easy to create something that mimics people's creativity compared with actually being deeply creative yourself. This is where the Lovelace test comes in. Ada Lovelace famously said, "Computers can't generate anything, for creation requires minimally originating something, but computers originate nothing. They merely do that which we order them to do via programs." This test is named in her honour as a true test of creativity. It tests whether the computer has originated anything. To pass the test, the computer needs to generate an item, which is then handed to the programmer, who needs to have no idea how the computer made it. This means that the person who made the computer, if he doesn't know, then the computer must have made it itself, and therefore it's deeply creative. Nothing currently available, however, will pass this test because of the consciousness issue again. However, there is a type of computer that may be able to pass this test in the future, because it's very difficult to read through the code of this type of computer, a quantum computer. Quantum computers work with a very weird and seemingly made-up area of physics. Niels Bohr, who was a respected quantum physicist, said, "Anyone who is not shocked by quantum theory has not properly understood it." This should be a warning as to the weirdness of quantum physics. The main principle that you have to understand surrounds Schrödinger's cat. This story about an experiment with a cat in a sealed box containing a vial of poison. The vial is set to be smashed after a random period of time, Therefore, the cat will die after a random period of time. Due to quantum physics, the cat can be thought of as both alive and dead at the same time. The same principle can be used to make a computer which can, in short, do two things at once. Scientists can use things such as a spinning electron. You fire just enough energy at the electron to maybe make it spin in the other direction. Therefore, the electron can be thought of as spinning in both directions. You can use computers like this to compare a load of variables to say which one is equal to, say, 5. The computer can test all the variables at the same time, and therefore comes up with an answer really quickly. This type of computer would surely pass the Lovelace test, because its creators wouldn't know in which direction the electrons are spinning. Therefore, it could possibly be deeply creative. However, we don't know at the moment, because there hasn't been a quantum computer successful enough to be able to do this sort of thing. I'm sorry that I've led you on a bit. I can't actually give you an answer as to whether computers are creative or not. I'm not aware of anyone who can either. I don't think that we have currently created anything that's deeply creative. However, maybe in the future we will. I'm going to leave you with this as a final thought. To have deep creativity, we first need to have an agent that has free will. If a computer has free will, how will we know? Thank you. Does anyone have any questions? Yes?
Don't look at me like that.
I'm worried about what you might ask. Go on.
If you take as a theory that the human brain is purely a set of numbers, calculations, synapses firing off, and everything can be calculated.
Yeah.
If you were to copy that insanely large amount of data and run it through a program that would run it like the human brain does, wouldn't you effectively have a human consciousness?
You're talking about making something a brain.
A true artificial intelligence.
Well, as in making an artificial brain.
Yeah.
The problem with that, then, is how you define what is and what isn't a computer. The computers that I've been talking about in this, which I probably should have explained, are digital computers using binary, ones and zeros. Brains don't use that. They use levels of current to send messages through the brain. Therefore, that would be analog, because there aren't just set values. You've got a whole range of values. And so, yeah, you probably could argue that something like that would be creative because it would be conscious. However, as per the question on the board, not knowing what is and what isn't free will, do we really have free will? Because we could just be programmed by nature, and that we could just be following a set of instructions predefined by God or nature.
It's like a true evolutionary approach.
Yeah, exactly.
Insane psychology. That everything we do is predetermined by previous experiences.
So if we're not creative, then computers surely don't have a hope. But if we are creative, then maybe computers could be creative. But digital computers, probably not. Maybe quantum computers and neuron nets, which I didn't really touch on. But that's making an artificial brain that does work digitally. Because the main problem that you have with a computer is that everything goes through the central processor. And this sort of creates like a funneling effect. Everything's going through one point of failure. Whereas in a brain, you've got lots of points that all the information's travelling through. And this makes it more robust and much, much faster. So if you create something like that, which the neuron net is what you're trying to create there, then you create a really fast computer that, the same as a quantum computer, could possibly be creative. And the other thing with that is that brains use roughly the same amount of energy as a laptop, about 10 watts, whereas a computer of the same power uses 100,000 watts. That's something to think about. Okay, question?
So say if you gave the computer the power to understand if something was good or not, and then you allowed it to think up an infinite amount of random digits, would it be able to analyse if something was new and creative?
Well, the problem, again, with a digital computer is that you can't get it to analyse it in that way, because computers just can't be conscious for a few reasons that I'm not really going to go into, because it's really, really complicated. But you're just going to have to take my word for it for the moment, I'm afraid, that computers cannot be conscious, digital computers, and therefore they don't understand if things are interesting or not. Yep.
Surely whoever made the computer is the person putting the creativity into the computer, so therefore it's them being creative.
Yeah, and that comes back to the idea of whether the computer's evaluating as it goes along, and the Lovelace test. But yeah, the person creating the code probably is being creative because they're analysing as they go along, they're creating something new, it's meaningful, so it fits all the definitions, assuming that people are creative, and we're not just following like God or nature, as we discussed a minute ago. Yeah?
Yeah, that's the same point with the annoying cartoon character thing on the stage.
Yeah.
That the person that's created that is creative.
Yeah.
And yet the people that are going to see it, that's what they're expecting. But if you're going to see the Philharmonic Orchestra,
Yeah.
you're expecting to hear all of the imperfections in the music that they're actually creating.
Yeah, if the people are creative. Back to the same question. You keep going round in circles with this because the problem is there's so many definitions for every single point that it's very difficult to get a meaningful yes or no answer. Because it's difficult to define the computer, difficult to define whether people are creative, difficult to define a brain. Yeah, anyway, question?
The chap who was doing the paintings,
Yeah.
what was he feeding the computer to get the paintings out? How much was he putting in to get those paintings? Or did the computer go from point A and then make up
The computer was going from scratch. It's just using a random digit following a certain set of rules. So the computer knew pretty much what it was aiming for. It knew that it had some colours, it knew what shapes were, it knew what people sort of looked like. That's the sort of information that you'd expect a person to have. And so the computer was using that knowledge that the inventor had given to it, and then it was randomly accessing that knowledge to create a random piece of art.
And who was checking it as it went along?
Who was checking it? Nobody's checking it. It was following logical steps to create the art, and that's why it's not creative, because it's just following logic. It's not evaluating as it goes along. So the computer doesn't know if it's created something good or not. It just thinks it has because it's done its bit. It's followed the rules.
And were those paintings put in an exhibition?
Yeah.
Did anybody buy them?
I'm not sure if anyone bought them, because you're not buying anything new, really, are you? I suppose the same as buying a print.
Is it any different to buying a painting painted by an elephant, which people do buy?
Well, but you could print out hundreds of those, though, couldn't you? And same as printing art, you can make. It's not there wasn't a limit to the amount that would produce it. They probably haven't got that much value.
Well, it's still an original piece, though.
Well, depends how many times you print it.
Well, but you know, having different paintings done.
Yeah. Yeah, if you print one of each painting, then yeah, they're original pieces, and you can sell them. I'm not sure if they did get sold. They were definitely put in an exhibition.
But we can do that. You know, all of us can do that. We can put a random number of splodges on, and yet we're not necessarily deemed as creative.
Well, it goes back to if you're evaluating as you go along. If you just splodge away, then you haven't really been creative.
Perspective on whether we're creative. So a random lodge thing could be created by a computer can't necessarily be deemed as creative.
Yeah.
I don't think so.
Another question from the back.
Couldn't you question that humanity's only interest with art and music is the appreciation of other humans' creativity?
Yeah.
And if there is no creativity, then is there any point in art or music?
Yeah, and that goes back to some of the points on the slide with the art about whether they've got sort of soul in the art. And then if it hasn't, sort of what's the point in buying it? If it is a creative piece of art made by the computer, but the computer doesn't know about the emotions in the piece of art, then sort of what's the point?
A lot of art is emotional, whereas like Van Gogh has got his blue period and he's got his red period. Surely, like, if the computer could come up with some sort of concept in knowing like an emotion of somebody, they could like transfer that onto the image. That would make it a little bit more creative than just.
Yeah, it would.
But then again, that's just another program.
The computer probably could recognise like different colours and link those to emotions, but it wouldn't really understand them because it requires consciousness again. But yeah, if you linked the colours with different emotions, then the computer could give you an answer as to whether it is creative. In fact, Birmingham University have created something. You show it a piece of art, and then it sort of lists facts about the art to you. It will tell you sort of the emotions of it, things like that, and then it will give you another piece of art that's sort of similar to that in, emotions and colours. But that's not really creative because it doesn't understand what it's doing. It's not conscious about the ideas it's making. It's just following rules of instructions about what it is. Yeah.
Show the computer, say, a painting or something, and told it to mimic it, but mimic it incorrectly, but with the same style or setting or thing. And would it be able to do that? Because wouldn't that in fact be creative?
It could mimic something, but then it's definitely not really creative. It's not creating the first definition, the dictionary.com definition of creating something new, and it's not creating a new idea then. Then you could argue that what is new, what isn't, if you just change one thing, is it a new idea? But in the content of this, it probably isn't. Yeah?
Could you say that we have the same level or lack of level of creativity as computers? Because we're basically, when we're being creative, we're outputting things that we've experienced, so are computers in a way.
Well, yeah,
we have experienced more, we have more plugged into our brain in a way.
Yeah, and that's one of the points we touched on earlier about whether we actually are creative, which is a whole other question, really, and there isn't a yes or no answer to that, because we can't look inside our brains in quite the same way. You can with sort of MRI scanners and things like that, and see what people are thinking when it happens. But yeah, it's an interesting question. And if we're not creative, then computers aren't creative either. So it all depends on how you define different things, and then these definitions link together, and that's why there isn't really a yes or no answer. I can't really answer your question because of that. Yeah.
It's sort of like different cultures. If you're from a certain culture, you're brought up in the same sort of way as the people around you. Mm-hmm. So we're not
creating anything new. You're following the set, and that's why computers theoretically should be quite creative, because they're not constrained by those social norms, whereas everybody else really is. But yeah, if you could get that, if you get the computer to give you a completely random idea, and then you did the art, then that maybe could be more creative. But then it's not just a yes-no as to whether it's creative. There's now scales of creativity, things that are more creative, things that are less. And it just gets even more complicated.
So it seems the computers can't do it without the human part.
No.
Whereas the humans can do it without the computer.
Wow. That's an interest. Maybe they can't. Maybe we're not creative because of the points touched on earlier. Yeah.
It's the mathematics side of it. If they're not really creating mathematical problems, because those mathematical problems were there.
The computer didn't know about the mathematical things. They're things that the computer hadn't been told, so it got them in the same way as the original person did.
But the maths was there, the numbers were there before, are always there. It's just a matter of not finding that.
Yeah, but it's creating a truly revolutionary idea with what it's being given. If you're creating art, you've already got the colours, you're not creating those. You've still got your primary colours, so it's the same in maths. If you've got the numbers and the operators, you're using those to create something truly
But that's saying that
a new
every
idea.
painting exists before people paint them somewhere. That's not true, but all maths problems exist before mathematicians solve them.
Well, so if you could link the colours together randomly, and you've got so many different options that somewhere in those options, like on a computer screen, if you look at that as a grid of different pixels that can take on different colours, then somewhere, if you gave each pixel a random value, you'd have every piece of art you can imagine. So they do already exist. There's so many different varieties.
I give up.
So many different variations. Same with
Are
the
you then
math.
trying to find infinity, effectively?
Well, there aren't infinite different things. There are a set amount of paintings that you could get on the computer screen, because you've got a set amount of pixels and a set amount of different states that the pixels can take. So it'd be the number of variations would be the number of states that the pixels could take to the power of the number of pixels, which is then a huge number. But, yeah. Okay. Any more questions?
John was going to ask something.
I was going to say, if you throw enough monkeys at a problem, like how you're going to, can you rewrite the complete works of Shakespeare? Then eventually, the theory is that they will solve that particular problem. But if you were to put a computer in the middle of enough humans to solve any problem, then you can pool all of that creativity and push it forward in a way in which it's very, very easy to get the right bits for everybody.
So, yeah, everything already exists. You've already got all the tools to make everything. Every piece of art, every piece of music, all the notes exist. You've got all the different ways of combining them. Everything that you could possibly imagine already exists. It just hasn't been put together. So if you linked a random element with everything, all the parts, then, after some time, you would create the thing, everything. So, but then has it been creative or not? But who really cares? Because you still got the object. So who cares if it's actually been created?
But it wouldn't have a soul.
Yeah. So, but who cares? Yeah. Question again.
So if we go back to the quantum computer, and we assume that quantum is the...
Now the experts left the room.
The quantum is the waves of the electrons overlapping to create the state of matter of the electron, then surely that to be completely creative as a quantum computer needs to step outside the boundaries of physics.
It depends how you define creativity again. Yeah, that is how the quantum computer works. But for the same reasons as any digital computer, it depends on how you define what is and what isn't creative. Because the quantum computer, the way that works, is can test everything at the same time. So if you created a powerful enough quantum computer, then what we were talking about a minute ago, with having everything, all the tools, linked together in a random way, the quantum computer should be able to do that in no time at all, if it knew what it was looking for, because it can test every single state at the same time, because it can do more than one thing at the same time. Therefore, it could create like a piece of art instantly if it knew what was interesting. But then it has to be conscious to know what it's looking for, and computers can't be conscious. So there's another problem. But if you could link like a person into that, if you could use a person's knowledge to know what is interesting, a consciousness that could be as quick as the quantum computer, then you could create any piece of art instantly. Any other questions?
Have you linked your brain to the computer and told it what to do?
How?
Somehow.
Yeah.
So, say you're having a scan in your brain, and when they do the thing where you think of something and they can see what you're thinking of, if that got linked to a computer and you told the computer what to do, would the computer be creative by creating what you were thinking?
It'd probably be you being creative, because you're doing the evaluation. If we are creative, then it's the evaluation is the key point, really. If you're evaluating, then you're probably being creative as we know it. Okay, yeah, another question?
So we only define what's interesting by what the social norm is in this respect. So surely the computer is always interesting in its respect.
Because you could have different social norms and then different things be interesting.
Yes.
Yeah. Well, some things...
So everything's interesting to the computer.
Everything could be interesting, and then that's like atonal music or abstract art. The computer could just throw a load of colours out in a random way, like random pixels, and then you could say that the computer's created art in the same way that as a person could, but it hasn't been creative as we've defined it, because it hasn't evaluated as it goes along. And so, again, we're back to the point of what is and what isn't creative, which, as I've told you, I can't answer. Bit of a pointless talk, really. Any other questions?
Fools are fooled by the computers. Because they're not being creative.
They're not being
You might be
creative.
fooled by those paintings, is what I'm saying. And some people might be.
People
and they
not.
might like them.
People think you're being creative. Just sat there churning stuff out. We've got a room dominated by artists. That's the problem. Right. Any other slanderous comments or questions? Okay.
Can I just congratulate you on the
Thank you.
fantastic presentation. It's also shown by the amount of interest in the question.